Welcome back to Summarize Science. Today, we're looking at a fascinating paper where researchers are teaching a robot to perform one of the most delicate medical procedures out there. Imagine navigating a tiny, flexible wire through the twisting blood vessels of the brain to treat something like an aneurysm. This procedure, called endovascular surgery, is incredibly challenging for even experienced human surgeons. The tools are minuscule and hard to control, and the surgeon relies on brief flashes of X-ray images to see. To tackle this, researchers created a larger, 3D, printed version of a soft robotic guide wire, which you can see here. This lets them safely test their ideas before shrinking the technology down for real-world use. They also built a series of mazes that mimic the complex forks or bifurcations found in our blood vessels. So how do you teach a robot to do this? Instead of programming every possible move, they used a technique called imitation learning. An expert operated the robot through the mazes hundreds of times, and an AI model watched these demonstrations to learn the expert's strategy. It learned not just where to go, but also a crucial skill: when to inject a contrast dye to get a new X-ray image, since you can't have the X-ray on constantly. The team trained the AI on 36 different maze layouts, generating over 600 demonstrations. Crucially, this included demonstrations of how to recover from common mistakes, like going down the wrong path. The real test came when they presented the AI with vascular mazes it had never seen before. This included rearranged mazes made of familiar parts in a new order and novel mazes with completely new turns and branches. The results were astounding. On the completely novel, unseen mazes, the AI model successfully reached the target aneurysm 83% of the time. This table shows how the main model, labeled Rs, dramatically outperformed other approaches where key features were removed. For example, a model that wasn't trained on recovery data only succeeded 22% of the time, showing how important it is for the AI to learn how to fix its own errors. But how does it stack up against humans? The researchers had two expert clinicians try the same navigation task using the same robotic system. Amazingly, the AI's success rate was on par with the human experts, who achieved rates of 83% and 78%. So, let's recap the important points. Researchers developed an AI that learned a complex surgical navigation task just by watching expert demonstrations. It successfully navigated a soft robot through unseen, complex vascular mazes with a success rate comparable to trained human clinicians. It also intelligently learned when to use simulated X-rays to see where it was going. What does this mean for the future of medicine? This work is a major step towards automating parts of highly delicate surgeries. While still in the research phase, this technology could one day make procedures like aneurysm treatments safer, faster, and more precise for everyone. Thanks for watching Summarize Science.